And I'll first give you the course outline, the workload that we have, okay? And actually, this course outline is the same as the functional groups that make organic chemistry, organic compounds, okay? So when you finish, you can also do your research and finish before the teacher. It is okay. When you finish this, then you'll be done with organic chemistry. In fact, at campus, they give you a course outline, and that's all. Once they give a course outline, then they have told. Okay? So the first thing you need to know is what organic chemistry is and what it entails. Okay? And we shall cover that today. Then you need to know the properties, different properties of organic compounds. How organic compounds behave. Okay? Are they polar? Are they non-polar? What's their boiling point? What's their melting point? Okay? How do they behave? Are they acidic? Are they alkaline? Like, you need to know how these organic compounds do behave. And then finally, the functional groups. Okay? The functional groups and the properties of these functional groups and how they are prepared and how they react. Basically, if you understand that, then you will know what organic chemistry is. Now, the functional groups range from, okay, before the functional groups, then you need to know how to calculate the molecular formula and empirical formula and the structure formulae of these organic compounds. But this one is more physical chemistry. Okay? So, I usually teach it, but if I first coordinate with the physical chemistry teacher, then it doesn't make sense for us to teach the same thing in physical chemistry and I also teach the same thing in organic chemistry. So we shall see how to do about it. Then you know the homologous series, and what are they? These are elements that differ in their carbon skeleton by just CH3. Their members differ in their carbon skeleton by a CH2. So that is a homologous series. And they include alkynes, and we shall talk about alkynes. We see the properties of alkynes. We see how these alkanes are prepared and how these alkanes behave. Okay? Their reactions that they do undergo. Then from alkanes we go to alkenes. We see how alkenes are prepared, maybe, and a functional group. And a functional group here is a carbon-carbon single bond. And a functional group here is a carbon-carbon double bond. So once you see a double bond, then that one means it is an alkene. And how they are prepared, okay, and the chemical reactions that they undergo, and the physical properties. And to explain the chemistry, why those physical properties. Then with alkynes, these ones have a carbon-carbon triple bond. Okay? So we see how these alkynes are going to be prepared under different conditions in a laboratory and on an industrial scale. And then the chemical reactions that these alkynes are going to undergo. So we shall also talk about that. So by doing that, then you are talking about organic chemistry. If you basically know how these functional groups are prepared, the physical properties, okay, of these functional groups, and finally the chemical reactions that these functional groups undergo, and the chemistry for those chemical reactions, then organic chemistry is going to be too easy for you. Then we also talk about benzene, and we see what benzene is. Okay? And benzene, it is just C6, H6, okay? C6H6. So it is usually represented as just this. So if you meet this somewhere, then you know that it is benzene. So you can either use a ring, like how I've done, or you can use these arrows. So we shall see why a ring. Okay? Why is benzene like that? And what are the properties to consider to term something as an aromatic compound? Now that is aromatic chemistry. When you go at campus, you find that chemistry. So interesting. So interesting. The criteria for aromaticity. Something must be planar. Something must be conjugated. Something must have delocalized electrons. And so on. So you discover that actually at this level, you are taught that benzene is the only aromatic compound. But when you go up with chemistry, you find that there are very many aromatic compounds other than just benzene. Okay? So we shall be able to introduce you to aromatic chemistry. Then, after benzene, we shall go ahead and talk about the methyl benzene. Here we just add sorry, a CH3. So, methyl, it is CH3. So, methyl benzene, we shall talk about it and see how it is. Then we shall talk about the nitro benzene. So here we just add a nitro group. Now these groups, we shall see how do they affect the aromaticity. Okay? Where we shall see the electron, those which increase the electron density, okay, on the benzene, and those ones have a positive inductive effect. And those which decrease the electron density on benzene, and those ones have a negative effect. And so all these ones, they impact differently on benzene. And so we shall find terms like ortho, para, meta, ortho, para directing groups, meta directing groups, and why they are called so. Okay? And we shall study that as far as benzene is concerned. By the way, if you have a question, you can always drop it in the chat box. I'll find a question. Then we also talk about chlorobenzene. So you just adding the Cl here and see how they are prepared and how do they affect the aromaticity, okay, of the benzene, the chemical reactions of benzene. Then after benzene, then we shall talk about alkyl halides, the halogen alkanes. And these ones, if this is the alkyl, then the alkyl is attached to a halogen. And this halogen, the X can be chlorine, the X can be bromine, the X can be iodine, but it can't be fluorine. Why? Fluorine is highly electronegative, that it forms unstable compounds with alkyls, which cannot exist, I think. So, usually they are these ones, these three. Okay? We see how they are prepared, and we see the chemical reactions that they do undergo. Now, we shall talk about alcohols. Now, this is what you like most. And an example is ethanol. Ethanol, CH2, CH3. This one, what you like most, sanitizer. So whenever I teach this, I always see a smile on people's faces. So we shall talk about this ethanol and other alcohols. And we shall see that it is just the R, the alkyl group, with a functional group OH. Now this OH becomes a functional group. Now what is a functional group? It is that atom or groups of atoms that do determine the chemical and the physical properties of a given organic compound. You can see this alcohol, the alcohol and the alkyl halides, they all have the R, the alkyl groups. And the alkyl groups are the same. But what is different is the X. Here there is a halogen, but here there is an OH. And so this difference is enough to bring about differences in both physical properties. And you'll be able to find that alcohols have, for instance, high boiling points than alkyl halides. Okay? Because of that difference, you may see it as a mere difference, but it is enough to impact on the chemistry of these organic compounds. Then you'll be able to find that alcohols, for instance, having the OH group and alkyl halides having the halogen, they undergo different reactions. Okay? And the difference in the chemical reactions is due to this functional group. So that is it. Then we shall talk about ethers. And now these ethers, they are formed from alcohols. Okay? They are derivatives of alcohols. In that, if your alcohol is the R, O, H, if you substitute this H with another alkyl group, then you form an ether. So this is the functional group, the R or R. So we shall see them, how they are prepared and how they do impact, okay, on the chemistry of these organic compounds. Then shall we talk about phenols? And phenol, it is nothing but benzene. Okay, sorry for in case I draw something wrongly, I'm just using a laptop, so we shall bear. So it is benzene, but in chemistry, in organic chemistry, you should write chemical symbols well, write them well. If you are drawing benzene, all sides must be equal with that ring in the middle. So this is just benzene with the OH functional group. So this is phenol. And we shall see that this one is different from alcohols. Yet they are alcohols, but we have aromatic alcohols and aliphatic alcohols. And we shall consider this benzene to be an aliphatic. Then we shall talk about carbonyl compounds with their functional group. And the functional group is, if you have this carbonyl carbon, this one. Okay? So this is what we call a carbonyl carbon. Now, depending on what is bonded to that carbonyl carbon, automatically this is an alkyl group. Now, if this carbonyl carbon here is bonded to hydrogen, okay, then you are an aldehyde. Okay? But if the carbonyl carbon is bonded to, so this is the carbonyl carbon, okay? So if the carbonyl carbon is bonded to another alkyl group, then this one becomes a ketone. Okay? So basically, those are carbonyl compounds. Then we shall talk about carboxylic acids. Okay? And with carboxylic acids, it is an alkyl group. Okay? With this carbonyl carbon, with this carbon atom. But now instead of this and this, for it has another OH. And we shall see how this one, we shall see that the chemical reactions of this one are totally different from these carbonyl compounds. Okay? And we shall be able to explain why after knowing the functional groups. Then it becomes easy to do the explaining. Then we shall see the acidic halides, whereby they are derivatives. Now, this one is a derivative of carboxylic acids. In that, in this, okay, in this, we substitute this OH with a halogen and we put the Cl. So, an acidic halide, it is something like this, CHO with this carbonyl carbon and then the halogen. So we shall see that this one is different from this. Okay? We shall see other. Then amides, this one is also another derivative of carboxylic acid, where the OH in carboxylic acid is substituted by an amino group. So this is O, something of this kind. Then the OH is substituted by an amino group. And we shall see that these two, they are different. And so they undergo different chemical reactions. So you need to know how they are prepared. Okay? And then the chemical reactions that they do undergo. Because if you know from preparation, then you shall be able to synthesize. Because we shall synthesize this from this. Then if you can't do that, then I don't know. If you don't know how to prepare all these functional groups, okay, then I don't know if you can synthesize any organic compound. That's pretty good. Then we shall have esters, and esters, they are also derivatives, okay, of carbonyl compounds, where the alcohol from a did I say derivatives of carbonyl compounds? That is just a mistake. They are derivatives of carboxylic acids. It was a slip of tongue. So in carboxylic acids, the OH in carboxylic acid joins another alcohol. Okay? So when a carboxylic acid reacts with an alcohol, what you form is an ester. So this is CH2. Anyway, depending on the alcohol, I was supposed to write an R. That R represents an alkyl group where it varies depending on the number of carbon atoms. So this one, it is an ester, and this is the functional group of an ester. Then out from ester, then we shall talk about amines, and we shall see that these ones have an amino group, and the amino group is attached to an alkyl halide. And we shall see that we have aromatic amines such as aniline or aminobenzene and aliphatic amines. And we shall see that the two, yes, they do have some similar reactions, but they have different chemistry. And we shall be able to explain the difference in the chemistry. Okay? We shall see that we have classes, actually. Alcohols, okay? Alcohols, carbonyl compounds, not carbonyl compound, but alkyl halides, these ones, and amines. They do have classes, okay? And we shall see the different classes of those compounds, the primary, secondary, and tertiary, and how the classes impact on the chemistry, okay, of these organic compounds, okay, and how these classes are prepared. So you also need to know that. Then finally, we shall talk about diazonium salts, and these ones, they are derivatives of amines, where the H, this is removed and you add another nitrogen, so you form something of this kind, where this is the Cl and this is the minus and this is a plus. So that is a diazonium salt, this one, okay? And we shall see how diazonium salts are prepared and the reactions that they undergo. Actually, these diazonium salts, they are good in organic synthesis, okay? So you need to know. Then finally, we shall talk about applied chemistry, and here we shall see concepts like saponification, soap formation, concepts like polymerization, okay? These two concepts. And when we talk about these ones, you see, actually this is the most important, because every day use soap, okay? Every day use polymers. I'm sure where you are seated right now, there must be a polymer around you. Hey, you can look around. There must be a polymer. There must be a plastic, for instance. There must be paper. There must be. You actually, let's not even go far. You are putting on clothes. Anyone who is studying while naked, obviously no one. Okay? So, polymer chemistry, so important in our daily life. Okay? And if you finish this, then you'll be done with organic chemistry.